All right, here's example 4. We want to express these two logarithms as a single logarithm and then simplify if possible. So both of these logarithms are base 5. So we can use the property right up here in the pink that's highlighted that we can go ahead and condense these to a single logarithm by multiplication. So we have logarithm base 5, and then we multiply 625 times 25. And then I'm going to go ahead and just change 625 to an exponential. So that is equivalent to 5 to the 4th power. And I'm going to change 25 to an exponential, that's 5 squared. Then I can use my exponent rules. Both of these are the same base, so I can add the exponents. So 4 plus 2 is 6. Now we have a logarithm of base 5 and an exponential of base 5. So we can use our inverse property, and they undo each other, so we're just left with the value of 6. All right, here's another one of these examples. Both of these are a logarithm of base 1/3. And so we're going to go ahead and multiply 27 times 1/9. And then I'm going to simplify that 27 times 1/9, which is 27 over 9. And we reduce that fraction to 27 divided by 9 is 3. And then I'm going to go ahead and change this logarithm to an exponential. So I'm going to change this just to an equation that looks like this. A logarithm of 1/3 is the base, and then 3, and then just change that to an equation to find out what it equals. Now I'm going to go ahead and just change colors here so you see now I'm changing it to an exponential. So our base is 1/3 raised to the x equals 3. Then I'm going to go ahead and change that 3 to 3 to the 1st, and we can flip this up to 3 to the negative 1 power because that negative exponent rule. And then everything else stays the same. So in the pink, I use my negative exponent rule. Now I have a power to a power. So what happens is those two multiply to each other, so that's negative 1x equals 3 raised to the 1st. So my bases are the same for these exponentials, so then my exponents equal each other. So negative 1x equals 1. And then we solve it for x, so we divide both sides by negative 1. And we get x to be negative 1. On this slide, remember that when you divide powers with the same base, you can subtract the exponent. So this is our exponent rule for quotient of quotients, or quotient of powers, and you are subtracting those exponents. Because the logarithms are exponents, you can subtract logarithms with the same base by finding the quotient of them. So here is our quotient property. And again, you can subtract, you can expand out if the m divided by n, so they would be subtracting. All right, so let's go ahead and use that property. So we have two logarithms. They are both base 5, and now notice the operation is subtraction. So when we condense this to a single logarithm, in the previous examples we were multiplying. In this case now we're going to be dividing. We're going to take 100 and divide it by 4. So we're taking 100 and dividing it by 4. Let me go ahead and simplify that fraction. So 100 divided by 4 is 25. And then we're going to change that 25 to an exponential. So 25 is equivalent to 5 squared. And now we have a logarithm of base 5 and an exponential of base 5. So we can use our inverse property. They cancel out. So we're just left with 2. Here's another one. We have two logarithms. They're both base 7. And the operation between them is subtraction. So to condense it, we're going to divide the 49 by the 7. And then we simplify that fraction. So 49 divided by 7 is 7. And I'm going to change that 7 in the parentheses to an exponential, so that's 7 to the first power. And now these are inverses of each other. We have a logarithm of base 7 and an exponential base 7, so they cancel each other out, and you're just left with 1.